All right, let's add some memory allocators. We only got a couple more, and we can really start or a couple more videos, and we should be able to start doing UI, like building windows and moving windows and handling events and stuff like that. But we're kind of still working on foundational stuff that we'll want. And one of the things we want is going to build kind of a interface, generic interface in C, so we can have function pointers, so we can pass in a production or standard like heap allocator. We'll have a debug allocator that keeps track of all the allocations and make sure we can count them, how much size we're using, when something isn't freed, when something is used, when something's double freed, when something isn't freed and leaked. We'll know. And everywhere in our system that's going to allocate, we'll pass these allocators through. So we really, at the initial part, create the interface. We're going to create a heap allocator that just is calling free and make, or uh, malloc and free, or even calloc and free under the hood. And our debug allocator will also call malloc and free, but it keep track of everything. But it's also a way to have slab allocators, different kind of allocators later on that we'll, I'm sure, want to use for cool stuff. Because I don't use a bunch of different types of allocators because I'm not a professional C developer. So I kind of refreshed myself on this pattern. I learned it from, I think I said the book, I linked it in a different video, but C interfaces. It's like a C interfaces and patterns. And it's just a linked list of headers that you keep track of, or allocations actually. But I'll show you the implementation. I'm going to do it. I've always copied it around, and I'm hoping that I can just implement it myself. I worked on it before and had it stashed away in Git, but I went ahead and just dumped it. I looked at it for a minute and dumped it, just so we could do it from scratch. Because again, if we can't do it from scratch, then we don't really understand it. So let's go. So it's our allocator is going to be in our standard library. We're just going to create a mem.h. I kind of like using maybe like memory prefix and like longer prefixes sometimes, but we're going with the short prefix because we're going to use them all over our system. So mem, gfx, os. So let's just keep it short for now. What we're going to have is basically a type that's called allocator. And it's a struct. I'd actually like since we're going to be passing through, I'd like something shorter. And I've thought about it, but I can't think of anything shorter that is nice, that makes sense. So, and then we're going to have function pointers that kind of represent our free, malloc, realloc. And we're going to need a way to shut it down, like call shutdown on it, like an init and a shutdown kind of, because we're going to have an initializer, but it's not going to be a function pointer because we need to call it to create this struct of function pointers. But when we're done, the system can just call shutdown from the function pointer here. It can be generic. And that the reason you do that, you want a shutdown function, is when you're done running your program, you can go, do I have any allocations left in bytes wise or in number of allocations, like current allocations? So you want that for the debug. And any kind of logging or anything you want to do to finalize the allocation. So it's easy to just have it. So yeah, I think that's it. Let's just what am I doing? We're gonna return a void for malloc out. I guess we're gonna return a void pointer, and we're gonna call it alloc. I think function. Oh, What am I doing? Wow. Every time I try to do something on camera, I just get fried. Am I tripping again? Does the return value, I mean, is this, am I crazy? Let's just, we're gonna have like a size, right? And then let's see. There's no way that you put this in there. Oh my God, am I that's that wow. Sorry, everybody. That was it's not that either. I'm gonna have to start this video over. Function pointer? It's like, I don't even want to have to look this up. Syntax. I want to do it myself. Let's do it before we look. All right, so we got our return type and the parameters, but you have to have the name for the function pointer itself. So I feel like it would be a void pointer because we don't know what kind of type we're returning. And then we want the name of the function and then the parameters, right? So like say size t for size. Am I crazy? Unknown. Oh, well, unknown type there. Yeah, that's fine. It's declared as a function. But it's going to be a function point. God, is that it? Why was it? Is it? Did I have it right and then I didn't have size t, and then like I didn't have size t imported, so I didn't know what that was. Holy, wow, that was struggle bus. All right, so let's be real here. We're also going to take some context here. Like every function is going to take some context, and it's essentially the state of that allocator. So we want the size of the allocation. We're going to return a void pointer because we don't know what the type is. Then let's take the where the allocation happens. File, and then we can do I think def should maybe be in AK types too, because we got stood in like our generic types, and we can kind of replace these with our own as we go forward without having to go update it everywhere. There's probably a bunch of places I'm already. Oh no, I'm not important anywhere else. I'm not important size T anywhere. That seems insane. These are going to get populated by some macros that we'll create as we go forward. And you know what? Does it make sense just to start out super simple and just so you can see the implementation? So what you would do to wrap this is go mem alloc, and then you pass in the allocator first. Then you pass in the size, and that's it. But what you're going to do is you're going to call the function of whatever the allocator you passed in, because you're going to pass in this, and you got all these pointers to functions. So you're going to do that. You're going to call it the function, but you're going to pass in again the allocators context, because we will have a void pointer to context here. We'll allocate something during initialization, or even for our like main heap allocator, it might just be like null. We won't, but we will want context. And this is just kind of mimicking, not mimicking, this is like C's poor man version of passing like self around, kind of, even though it's a property of the struct. But all right, and then we'll pass in the size, and then we'll pass in the file wherever we call this from in the line. So when we actually use it somewhere, we would do mem alloc, and then we'd have an allocator named alloc and say, 64 bytes, and say, my type of thing equals, and that's it. So it's just like normal. But we can swap these out. We can have multiple at the same time, and every function will take this generic type. So we're just kind of getting a little generic. So we're going to do another one. Might as well do free. And you're going to take in a void pointer. And really, again, we need a void pointer for the context, but we need a void pointer for the allocation. And I don't think we'll need file or line, right? Because we're not going to track, not going to look anything up by that from where we free. That might change, but let's just do without it for now. We might want it because if something happens when we try to free something we're not expecting. Yeah, we'll do it. I can already see that we're going to need it. Void shut down function. We're just going to take the context. I think it doesn't need anything else. We'll worry about realloc later. We can kind of do the same for free, but free is going to take a pointer to the previous allocation. We're going to do a free function. We're going to pass in the same. We're just going to kind of do the same thing with a pointer instead of size. Shut down. We're going to pass in a context. I don't think we care about anything else there. Do you guys like, I think this is the opposite of, like, this isn't big notation, but they're not being exported. Kind of like that, or do I like that? Is that too verbose? Like I said, let's go verbose up front and then undo it after. Okay, so this is kind of all we need. We're going to want a mem allocator t mem, then what? Heap allocator create. So one of the things I saw when I did this before is you can do an allocation, right, for the struct itself and return the pointer to it. But what if you just return? What if you don't return a pointer? What if you just return by value? Since everything is a pointer, like everything in here is a pointer. I don't know if it matters. I guess you're gonna want a pointer because we're calling by pointer here, but we could just call like this. Our existing pattern though for stuff like this is to do a pointer, like allocate the struct, but you could just return by value, but maybe we'll experiment later. Maybe we'll just do pointers for now and experiment later. And then what do we want to debug creator? I don't, let's do the heap one first because it's way more simple. And then we can pass it to our system, see it working, then try the debug. And let's just do that. So we'll go mem heap.c, right? Yes. So, no, not pragma. So what we'll do is name this heap free, maybe? Because this is internal. And the cool thing for this one is we can just kind of ignore this stuff. We'll do this probably for each function. Like we don't care about this because it's just the standard allocator. We're just passing through basically free and wait, did I say free? I meant oh. And then imagine we have a few of these functions. I'm just going to say return null just to get this to shut up. Also, we are going to care about size, but for the purpose of explaining, let's just get rid of all our errors. And then we would have, the function we created here. Yeah, we can. You're going to use your normal allocator here, just like free. This is the one place because it's kind of part of startup. I always forget. I have to look this up literally every time. I can't remember if it's one then the size. Or if it's size then the number. I think it's count and size, yeah. So we are sure we got that. Then we just go, we can just set all our function alloc equals heap alloc return done. So we'll set, our additional ones here once we create them. So let's just do it. And I think we're just gonna use cal. And for us, we're strict, so we're just gonna assert and blow up everything as usual. I mean, it's as simple as that. We're going to assert that we have a pointer. We don't want to free something that's already been freed. So we're just going to blow up there, catch bugs, and free pointer. That's it. And then for us, shutdown is done because we don't have any context. So we're just going to unuse context. We're not returning anything. Name this heap shutdown. Since we're not doing anything, you can, maybe we don't even set it. Maybe we just check in the macro, or do we want to do that? Let's just do it like this first. Excuse me. All right. We might just, we might get rid of that. I don't know. Is that all we have to do? Let's just get rid of debug right now because that doesn't even exist. Let's go try to do it in main. And find out where we're allocating. What are you allocating here? Let's just go mem heap create. That's a pointer. Maybe it's cool if it's a pointer because we don't have to pass. Well, it's just a bunch of pointers. It's passing one pointer versus four. It's probably doesn't matter. Let's just leave it as pointer for now. Does this allocate? I'm pretty sure it does. Maybe not. Oh, free. I see. Oh, there's calc right there. Perfect. That's what we should just be searching for is alloc around this system. So mem allocator. Let's just replace everything with alloc. We need to import that. We're going to have to display. It's going to be a pointer. Memory. Did I do a pointer here? No, I did not. So this is where we're going to call mem alloc the name of the allocator, comma, the size. I think, fuck, we might have to like manually type this out. Is that expected for have one? Oh, yeah, is true. Context. Makes sense. No big deal. Somewhere else is going to allocate. Somewhere's going to free. So we're going to change this to mem free. Alloc, we don't have it yet, but we are going to pass it in. Mem allocator alloc pointer. And we need to put it in the header, but let's make sure we're not using anywhere else. Now I can just pass in alloc. Done. Does this do the same? Yes. I wish I knew how my editor, when I updated this, I know how to rename everything, but to refactor parameters, I know how to rename. I'll just do it manually. Now that I know people are watching, or not, not many, but people can watch, I want to speed things up because I feel bad for making people watch me type slow. So we allocate in, or we do this in the allocator now. So I don't think we're going to return null. Like we're going to blow up. Do we care about that? Do we need to do error checking higher at the stack, or if we're out of memory, are we going to be honest with ourselves since this is a test project and just nuke everything? If it ever becomes a problem, we could just search for mem alloc and find every place allocator can fail, but that could be annoying. But we're just asserting right now anyway. Yeah. But I think that we don't need to do that. Also here where we're calling this alloc and then passing in alloc, maybe this should be malloc. But I didn't do that because we use calloc under the hood. I'll take the performance hit. It's fine. So I didn't want to confuse people thinking it's not going to zero out. So I named it that. Whoa. Is that it? We don't allocate anywhere else there. So this is kind of a zig way passing allocators around, and I don't know, I'm kind of digging it so far. Just a dependency like anything else. And it's caught in my other projects where I've done this like over years and used the debug allocator. It's caught so many memory bugs. Maybe this is more common than I know. I mean, it's been in books since I don't know how that book is, 80s or 90s. So I guess I'm newer. So where else? So we're not calling calc from anywhere except for inside the allocator. Okay, cool. All right, project still runs, still allocating. So we said we were going to add that. That's good. Good. It's fine. Port memory. Create delete. Oh, we did forget one thing. We would have found out soon enough, but we're not calling shutdown at the end of main. So we're doing OS in it, then memory in it. So right before OS shutdown, we'll do shutdown. Oh. So let's try something. Let's do that. All right, so that works fine, right? But what if heap, this is kind of like a not that realistic of a scenario, but if we just, it's less boilerplate, but you're not creating, it's less boilerplate for each implementation of this allocator, but there aren't many of these out. There's only going to be a handful. So watch when I quit, it should probably panic. Yeah. So one thing you can do, just say if there's a func shutdown. Does that work? If a func shutdown. Then call, that might not work. I don't know if that's gonna work. I feel like that macro's wonky. Oh shit. Excuse my language. I don't know if anybody cares if you cuss actually. We're gonna do probably a do while. Wait, what? Do that. Let's do that. If we have a function shutdown, then call it. It's not that bad. It's only on that one. Let's do that. It's kind. I mean, it's probably the same amount of code. We remove that. But we dump this function. I mean, almost every other one is going to have this, so it's a real, probably not worth the effort that we just did, but we've already done it. And we just handle it in case somebody forgets it, I guess, but it's going to be exceedingly rare. So we created it and used the heap allocator. I think that's worth a commit on its own. Add. All right, so I'm going to copy all this. We're going to create a new file for the debug allocator. Let's just get everything, actually. Anything named heap, we're just going to rename to debug, right? And we're going to need a shutdown, because we will need that over here. This is a dumb test, but it is a different allocator. So let's just go debug, even though there's no real difference in the code. Mem debug. What did I name it? Mem debug create. Oh, I didn't put it in the memory header. Sweet. So it is wired up at least. Now we have to make it special. All right. So essentially what we're going to do is, actually I'm going to take a 2-second break because this is going to take a minute. All right, let's go. So yeah, what we're going to do is for every allocation that we make, we're going to stick a header in the front of it. And the way we do that is create the allocation of the size requested plus the size of a header. Do whatever you want in the header, set the location of the allocation, the size, the information you want to store for the header. And then the pointer you return is the original pointer plus the size of one header, the header. So then the user can have all that data. But when you free it, you obviously get back the user pointer, and then you need to subtract the size of the header to get the header and check the information there. So let's create a header, and then we'll need some kind of state to track all these headers. This is internal to here, so we can be like short with the naming. I actually take that back. Now that I think about that, this isn't internal. I mean, it is, but if you had if you had multiple, yeah, if you had multiple C files, like multiple implementations that each had a header, you'd need to like subname these like a debug header, mem debug header or something like that. But let's just go header for now until it becomes an issue. We'll watch it break and remember why. So this one, we're going to need a pointer to the next one. So to reference itself, you need, you gotta, we'll go struct header pointer next, right? And I don't know what order I'm going to do these in just yet. I don't know why I did that. I32 line. Wow. Size. And do we want anything else? There is a little, I don't know if we want to do it now or later. I might as well do it now. There's a thing, if you just put, you can basically stick a magic number in here. Magic. I'm just going to call it magic. And then you have actually we'll just do an enum const mem debug magic. I did it as, in the past, I did it just like allocate, maybe just even alloc. Oh, probably, how far, what, that's 816 alloc. 24, 30, let's just do that. I'm just going to start repeating it. It doesn't really matter. I just wanted something recognizable kind of. And so per allocation, you stick that in the header. And then when you're about to free or reallocate, you make sure that it's that number. That means like, oh yeah, we're the ones that did that. To make sure if it's off, then we know something's off. We know we didn't actually reach the right header. We just assert that. That's just for that. All right. Wait, so we have the header, but we also need the state of the allocator itself. Like, you're going to need a header pointer, like the first one, right? And then let's do that there. That's probably the most important. And then I don't know what size these need to be. Let's just do size T for now. And this is allocation, maybe count total, like how many allocations and how many we have currently. Total will just keep incrementing. Current, when we free, will come back down. And I think there's a bunch of stuff you can do here, but let's just do size for the number of bytes and how many we have. Like how many allocations and what's the total size and current size of them. That's cool with me. So we are going to use all this stuff. So we're going to assert context. We're going to assert the, do we have to assert size or anything? I mean, it's already 64-bit. Size is greater than 0. So I'm pretty sure you can pass, you can pass 0 to realloc, I think. But we're not going to allow it. Let's be strict. This is all our code. You could do, will never be here, but it's maybe since it's unsigned, you might catch something, because if you do assert the size plus the size of the header T is less than what's the size, like the limit, like if you do uint 16 max, what's the version for, can we go there? Size max? Is that size T? Yeah, uint pointer max, size max. So we're going to get a pointer to the header. Let's just call it maybe header. The size plus size of header. Right, that's going to give us a pointer. But, then what? We go, actually, I mean, is that stupid? Oh, what if we just, is this more? I mean, it's not, it is to the header, but there's more behind it. We're going to do a lot more, but you could just do void user pointer equals header don't need a T. +1. Like user pointers to the part that they get to use, after the header. I don't know if I like that. I kind of like pointer because it's the one, but we can cast this to. I think that's better because then you just cast the pointer to a header so it knows the size. So when you add one, it adds the proper size. But then we don't have anything called the header. Well, let's just keep going for now, actually. So we need to get the state too. State equals, do I have to cast that? No. We can just cast it straight over. You don't even need to do this explicitness, right? So I mean that's just how it works. You can cast a void pointer to anything. I think that's how malloc works anyway. So I'm gonna keep this down here because you don't even need the user pointer until like the very end. So we're not even gonna update the state. Since we assert blow up, it doesn't matter, but we're gonna wait till after we get the pointer to update the state. I think we could just do something like this. So size doesn't work like that, but so everything gets incremented, right? Current and total, yeah. We gotta do we set the state? Which way are we going? The first allocation needs to become state head, right? Hmm. But if it's not the first one, we're just going to keep overriding head. I don't like how we don't have something called header, but I like this being called pointer for now. Oh shoot. Should I do this? I got the raw pointer and then the header. Maybe this is better. I don't remember what we've done before. I mean, it kind of makes pointer. we even use pointer anymore? I don't know, because if you were, I mean, I don't like that header doesn't say like it's header plus. End user capacity. I'm gonna probably change it. I don't love that. But so if state becomes header, then if or I'm sorry, if if head becomes header, whatever's in if state head not null, maybe we don't care if it's not null, then header next equals state head. I feel like that makes sense, right? But maybe we don't even need this. We need to, let's keep populate. So we need magic. Maybe this is mem debug. It doesn't like that because the type. Let's, oh, am I dumb? That can be a U32. I probably wanted it to be. Okay. Line. I don't care about line either. It can be U32. And that's 64. That's 128. And then the pointers can be after with 64 each or whatever architecture. So magic header line. No, file's better first. Header file equals file. Header line equals line. What did we say? We said we were going to start using I32 for stuff. And let's be more explicit. Const. Oh, that's unsigned by default. Okay, well, let's keep just fumbling around. Magic is going to be you. I mean, we can cast this and stuff, but since we're using like actual memory, it's probably better unsigned. Does it matter? Because even if no matter which way you interpret it, if you're testing U32 to U32, it should be the same. If it's I32, I32, but whatever. File line. We need to store the size, magic line size file next. And then our header next should be state head every time, because even if state head is null, that means it's the first one, so state header next can point to null. I think that's right. I think we're good. All right, so that's free. Let's hurry up. This, we're not gonna be free in that. Let's just make a comment so we don't forget, because this is to the user. We don't want to free there. We want to free before the header. Where I don't know why I needed to copy that. So we're going to get the state. Maybe we don't want file line in here. I don't. No, I don't know. Let's see. So you gave us a pointer. And we're going to get a header from it, right? A pointer to a header. And we can say that's header t pointer to pointer -1. Because we're going to turn their pointer into a header, subtract 1, which is the size of a header, and then boom, we're freaking at header. That's, and then we can assert right away that header.magic is magic. But not the, why isn't it liking this? What the hell's going on? Is it my editor? We're going to assert header magic. Oh, equals. Was I doing a comma? We'll just say bad free at line D. I'm just gonna put quotes around this file name so it's obvious, and we'll say file line, right? Boom, done, easy. So we probably want to, we're gonna have to store this size. The old size is the header size, because we're gonna need to subtract it. Or do we just do that right now before we free? Is that, because if it fails to free, we're just gonna, if anything fails, we're gonna blow up anyway, right? So do we care? No, this is totally wrong. Total, we don't touch. Current, we touch. So now we need to loop over. think what we're gonna have to do, get another pointer to a pointer. State head this part is the part that maybe for C developers is just second nature, but this part is where I gotta actually think. If we're dereferencing it, you have a pointer to a pointer so you can update it, like keep looping through them. But if you have a current, then that means we found it and we actually probably want to update that one to be header, like go around it, right? Otherwise, current equals. No, this is gonna be. Wait, I'm dereferencing. Oh, do I need to wrap this to because the dereference? But we want to ensure that if we keep looping through, we want to blow up if we didn't find what we're looking for. Because if it's not there, then we have a problem. Because then that it looped through every allocation, couldn't find the allocation that we're looking for, which is a problem. That something's wrong at that point. We can actually free header, right? I might have to like test this out because this part. So we get the one at head. We're gonna go through head, looping through next, as long as there's another one, and then eventually it's going to be null. So this will fail. But then for each one of these, we're going to test it and see if it matches our header, the pointer to our header. If they match, and if they do match, then we're setting the current one to the next one because we're essentially taking ours, one we're deallocating out of the chain, out of the linked list. So we're pointing it to the next one, which I feel like I'm leaving something out, but I don't know, should we? Oh, let's do shutdown. So I'm going to leave this for now because shutdown is going to help us out with debugging this a little bit, because what we'll do is say, this is where we can check if we have any allocations still left over. State equals context. This will probably get a little bit better over time. But if state dot allocation count current, we can get out of printing each line, but let's just do printf. There are still allocations worth current count size current. Oh, that the UL. Actually, let's just do or. We're going to keep it like really dumb right now, but this can get much better because it can say where it was allocated, where they, you know what I mean? It can, where they happen, what line were they allocated, and how large were they, all the stuff that we have in the header. And the header can grow and we can show more information. Current. And we're not even doing anything with total yet, but we can. Let's just try. We might blow up right away. All right. Yep, we did mess up. Perfect. We don't want this. We want our state size of state. So yeah, we need to allocate the state that we're going to be passing around that's on the memory allocator. Oh. In this memory allocator, there's this context that we pass to each function that has all the state, right? So we need to set it. We need to allocate the state and then set the context here to the pointer of the allocated state. Okay. Okay. So let's actually go into graphics or somewhere we're allocating. And let's just delete some of these frees and do it again. Yep, see, there's still one allocation worth. All right, that's sick. Let's do a couple. Yep, two. Okay, I like that. It's working. You know what's funny? What does that say? 60. What is that? Oh, I couldn't figure out. It said 6. The other one said 192.0.0.0.0, and then this one had an extra 16 bytes in it. I was curious if this was actually 16, but it wasn't making sense because U32, but it's a pointer. So 64, so that's 8 bytes plus 4 is 16. So that makes perfect sense. All right. So we have, this video is probably getting super long, but there's our like rough, not rough, but like super basic functionality. We still need realloc, but that is the whole purpose of this thing. And like I say, the debugging will get better. I'll probably do some off screen and just, you could, the hard part or the complicated part's already done. So if you understand this part, everything else is just additional fields and checking and stuff. There's some other cool stuff you can do. Some of it's new to me as well. So yeah, I think that's enough. How long's it been? An hour 10? Perfect time. Thanks, everybody. Peace. Well, hold on. Not peace yet. Let's wrap up what we would actually do. commit stuff. Add and use a debug allocator. If you're watching these two, I'm going to be pushing this up to Git. I'm just kind of waiting to get to 10-ish episodes and then take what I've learned to just pumping these out and kind of refine what I'm doing. I think at like the 10th one, I'll say something about like what the bigger plan is and all that. I just kind of wanted to dive in, start pumping videos out and see if I even enjoyed it and if it was I could type on screen. So, all right, see you later. Bye.